Beautiful people, and welcome. In today's video, we will be discussing the surface area of cones and pyramids. Both are going to be covered in this video, along with some composite figures and the surface area of them. Disclaimer time, I am human, so if I make a mistake, just let me know where the mistake occurs, so that way I can learn from it. So this here is a quick sketch that I did of a pyramid. Now, some things that you want to pay attention to is that the slant height is from the vertex to the middle of one side of the base, okay? Has to go from the top all the way down to the bottom. If you have from the vertex to the edge of the base or to the corner of the base, you have an edge. You don't have a slant height. So big difference between slant height and edge. Slant height will go from the vertex to the center of the base side, and the edge will go to the corner of the base side. Now, we also have the height. Remember, height is always perpendicular to the base. So it is from the vertex all the way down, and it meets at the base at a right angle. Let's go ahead and I'm going to shift this up just a little bit. I'm going to give you a flat view of the pyramid. Now this here is, it looks to me like it either could be a rectangular pyramid or a square pyramid, but here's your base, whatever it is, here's your base. And then here you have your height, you have your slant height, you have your slant height, and you have your edge. So notice the difference. Your edge is going to be on the outside here of your triangle, which is your side of your pyramid. And then your slant height goes from the vertex, from the pointy part of the triangle, the top part, all the way down to the middle. That is the difference. Let's talk about formulas. Formula for the lateral area of your height. If you remember my other video, lateral area is the area without your base. So whatever it is, you're adding all the small little areas together, but you're leaving the base out. The easiest way to find the lateral area of a pyramid is to follow this formula. You have 1/2 times the perimeter of the base. So let's put that in. So we have 1/2 times the perimeter of the base times the slant height. Now, once we have lateral area, surface area is super duper easy because we take your lateral area and we add what we originally didn't add. So in lateral area, we didn't add the base. So in surface area, we're taking the lateral area and we're adding the base. When you're solving for your surface area, you want to find your lateral area first. Find your lateral area and then add whatever area of your base is. Now, here is another formula for your surface area. This I have replaced lateral area, LA, with the actual lateral area formula. So it's 1/2 times the perimeter of the base times the slant height. We're adding the base area of your pyramid. So this is the information you need to know for your pyramid. Now let's go ahead and do exactly the same thing for your cones. So here is a cone. Again, when I see cones, I'm thinking ice cream. I'm also thinking like party hats, birthday hats. Here's your cone. Here's the base of it. It's at the bottom. It could be flipped, so the base could be at the top, but you have here your base. Your height, again, once again, is perpendicular to the base, so you have it at a right angle. It goes from the vertex all the way down. Your slant height for a cone is on the edge of the cone, shown here. Let's go ahead and show how this would look like if it was cut open. Here again is your slant height. And then just to let you know, the perimeter of the base, so what it is circling around here, so it's not going around like a square, it's going around a circle. So if I was to start here and cut it open, my cone would open up like this, but this section right here, this bottom section, would have been originally the circle. So when we're talking about like the perimeter, we're talking about the circumference. Okay, so this is the perimeter around the circle, which is also known as the circumference of a circle. Top formulas, here it is. We want the 1/2 times the perimeter of the base. And then you can kind of see why we chose to do pyramids and cones together, because the formulas are exactly the same, kind of. So we have 1/2 times the perimeter of the base times the slant height. So far, everything's the same. Where it changes is knowing that we have the perimeter being your circumference. So here in a thinking bubble, in the green thinking bubble, let's talk about that. I have 1/2. This is how I did it. 1/2 and 1/2. The perimeter of the base is our circumference. So this right here is your circumference. And then you're multiplying that by your by your slant height. Now, notice that we have 2 being multiplied by 1/2. So those 2's cancel out. They undo each other. So we're only left with pi r L. If it helps you to write this formula down instead of this one, I highly recommend it, okay? Just remember one formula, which is 1/2 times the perimeter of the base times your slant height for lateral area. And that will work for your pyramids, and that will work for your cones. For your cones, you're just going to have to simplify the 2 with the 1/2. Now, again, very similar to pyramids, our surface area formula is lateral area plus the base, the area of the base. Capital B means area of the base. So lateral area was what? It was pi r times our slant height, or you could have done this version here without simplifying. So here is our surface area formula for our cone. Let me write that in. So this is surface area for cone and don't want to get you dizzy there. Surface area for a pyramid. Let's go ahead and do some examples. Let's jump in. I'm going to zoom out just a little bit to show you all of our formulas. Okay, this is our pyramid side. This is our cone side. Again, if you get that mixed up, that's okay, because the lateral area formulas and the surface area formulas are the same. What we have inside of those formulas are different. For example, the base for the pyramid is different than the base for the cone. The cone has a base of a circle. That's going to be different, but other than that, the main things are the same. 1/2 times the perimeter of the base times the slant height, add a base to make it a surface area. All right, example time. We're gonna do this, few basic ones before we jump into composite figures. Got my pencil here. Make sure you're using a pencil when you're doing these, because mistakes can and will happen. And of course, if I make a mistake, let me know. All right, let's name it. Well, first of all, I know it's a pyramid because all of my edges meet at one point, so I know it's a pyramid. But when it's asking for a name, it's asking for the full name. So what type of pyramid is it? In order to know what type of pyramid it is, we have to look at the base of the pyramid. So here's the base of the pyramid. And one thing you notice, it is 5 on this side and 5 on this side. So that means I have a 5 by 5 square as a base for my pyramid. So that means I have a square pyramid. So let's go ahead and calculate the area of the base. We know that's going to be needed in our surface area. So area of the base, 5 times 5. And that is 25. Now let's calculate the perimeter. Here's the thing with surface area, I always highly recommend drawing out your base so you can actually see what you have. For example, I drew a square, and I have 5 by 5 by 5 by 5, right? It's a 5 by 5 square. So I have 5 on each side. So what is my perimeter? I have 5, 10, 15, 20. Or you can say 4 times 5, which is, again, 20, or you can just add them together. Now let's see slant height. Slant height, again, keep saying again, I apologize for that. Slant height is from your vertex to the middle of your to the middle of your side base, right? The side of your base, it's to the middle. From your vertex all the way down to the middle, that is your slant height, and that is at 9 feet. You can write feet here, you can write it without. Lateral area, okay. So here's when, if you don't have this memorized yet, and I don't expect you to, you can have it memorized later. Here's your cheat sheet, you're looking at that cheat sheet. Lateral area is 1/2 times the perimeter. Woo! My brain is working a little faster than my hand is. So 1/2 times the perimeter of the base times your slant height. So 1/2, what's the perimeter of the base? We already have that information. Perimeter of the base is 20 times your slant height. Your slant height is 9. Take out your calculator. If you don't need a calculator for this, good for you. So 20 times 9 divided by 2, and I have a lateral area of 90. Now, whenever you're solving for lateral area, you must include units. So I'm going to erase this. Ran out of room, so instead of writing LA, I'm actually going to use that for units. And so our units are feet. What are we trying to find? Area. Area is always squared. That's our lateral area. Now, surface area is lateral area. Whoop. Telling you guys, pencils are fantastic. All right, lateral area plus 1 base, because pyramid only has 1 base. And again, this is the area of the base of the pyramid. Capital B means area of the base. So lateral area was 90. Area of the base, we already did that, is 25. So 90 plus 25 is 115. So our surface area for this pyramid is 115 feet. Area is what? Always squared. All right, let's do another example. All right, let's go ahead and start. I have a pyramid. Let's draw this out a little bit more. And it looks like my base of the pyramid is once again a square. Let me shift this up. How do I know it's a square? Again, I'm going to draw it out. I have a 16 on one side, 16 on another side. So then name, I have a square pyramid. Area of the base, 16 times 16 is 256. Perimeter of the base is 16 times 4, or 16 added 4 times, which is 64. Slant height, remember slant height is from the vertex to the middle of your base. Now, one thing I didn't mention, I did mention in a picture here, but I don't think I actually said it. Your slant height meets the side of your pyramid, side of your base, at a right angle. So this is a right angle. So this right here is a right angle. So unfortunately, that information is not provided to us, but we do know that it meets at the middle. And then we have a 10. So let me show you what we actually have. This is what we actually have. And then this right here, because it meets at the middle, we're going to take 16, we're going to divide it by 2. And we have 8. All right, let's talk Pythagorean theorem. So I have my hypotenuse opposite my right angle. So I have my slant height squared plus 8 squared is equal to 10 squared. So I have my slant height squared plus 64 is equal to 100. I'm going to subtract 64. So what do I have? 100 minus 64 is 30. Ooh. 100 minus 64 is 36. I knew the right answer in my head, and my calculator wasn't matching that. So 36. So I have my slant height squared. Remember, if you are taking the square root for an equation like this and solving for a variable, your answer is always going to be plus or minus. However, we are talking about a unit of measure, and units of measure cannot be negative. So I'm going to take my square root, but only take the positive of that. So I know that my slant height is 6. So when it's asking for slant height, my slant height is 6. Lateral area, again, it is 1/2 times the perimeter of your base times your slant height. So 1/2 perimeter of the base is 64. Your slant height is 6. So 64 times 6 is 384 divided by 2, and that is 192. Again, for lateral area, you must use units, and you must tell me that area is squared. And the reason I wrote U is because I didn't actually provide units. There are no units on here, so we write U for units. Surface area is your lateral area plus one area of the base. So lateral area was 192, and the base area, we already calculated the area of the base, is 256. So I'm going to add those together, and I get a total of 448 units. What are we trying to find? Area. Area is always what? Squared. All right, let's go ahead and continue. Now we're going to have an example of a cone. We're going to do exactly what we did here. We're going to have that information, but I'm going to show you a different way of organizing this. So first thing we want to find out is we want to find out the lateral area. So lateral area is equal to 1/2 times the perimeter of the base times our slant height. So what we're starting here, 1/2 times the perimeter of the base. We know the perimeter is a circle. So what is the base? The base is a circle. Perimeter of the base is circumference, which is 2 pi r. So 2 pi r. Slant height is on the side here. So we want the slant height. Again, my 2's cross out, so I have pi r times my slant height for my lateral area. Now I need my slant height. My slant height is not provided. Again, for the, I keep saying again, I apologize. I don't know why I keep saying again. For the slant height, it's from the vertex to the side of your circle. So that's your slant height here. And unfortunately, they don't provide that information for you, so you're going to need to solve for it. Good thing we know the height, the actual height of this cone is 80, and we know that the height is perpendicular to the base, and we know that the radius is 60 yards. So let me draw what we have. Here's our slant height. We know the radius is 60. So if 60 here, 60 here. And we know that the height is 80. So therefore, we have an opportunity to use the Pythagorean theorem. Remember, hypotenuse is always opposite your right angle. So I have 60 squared plus 80 squared is equal to my slant height squared. 60 squared is 3,600. This is 6,400 because 8 squared is 64, and then we put the zeros in there. We're going to add those together and then take the square root. So I have 1, 0, 0, 0, 0 is equal to my slant height squared. Taking the square root of that, we have that slant height is equal to, I'm going to say plus or minus 100, but we are taking the measurement of something, so therefore it is only positive. So slant height is 100. All right, so let's go ahead and calculate this lateral area. Lateral area is pi, radius is 60, slant height is 100. So I have 6,000 pi for my lateral area. Again, we need units. Units are yard. What are we finding? We're finding lateral area. Area is always squared. Now from here, we're going to go to surface area. Surface area is your lateral area plus the area of your base. We already know what your lateral area is, and that's 6,000 pi plus your base, and your base is your area base, so it's pi r squared. So we have 6,000 pi times pi, plus pi times 60 squared. So I have 6,000 pi plus 3,600 pi. We're going to add those two together. And I get a surface area of 9,600 pi. What are my units? Yards. What are we trying to find? Area. Area is always squared. So this is my surface area, and this is my lateral area. So just another way for you to organize your thoughts. If you prefer this method, that's fine. If you prefer this method, that is also okay. All right, let's do one more example. A cone. So we know it's a cone. I'm going to draw a picture of a cone. You can draw it this way, you can draw it the other way, it doesn't matter. Whenever you're dealing with word problems, just immediately start drawing pictures. A cone has a lateral area. We know lateral area is from the vertex all the way to the side, is 100 pi. And a total surface area. So we know surface area, lateral. Ooh, do you guys see how I made that mistake? Shame on teacher. Shame, shame, shame. I hope you were screaming at me through the screen. Shame. Lateral area, not slant height. Lateral area is equal to 100 pi. I was thinking, why that was weird. And then surface area is 136 pi. And we want to find the radius. So we want to find r. So this is a little bit of a backwards problem because we're not trying to solve for lateral area, we're not trying to solve for surface area, we're trying to solve for the radius, which is used in both. So let's see. Let's start with the formulas. We know lateral area is 100 pi, and we also know that lateral area is 1/2 times the perimeter of the base times our slant height. And I also know that the perimeter of the base is 2 pi r. And I also know that we can simplify the 2 and the 2 out. So I know that 100 pi is now equal to 2 pi r times the slant height. Okay. Here's our unknown. However, we also have this slant height that we don't know, right? Because they only gave us the lateral area and they gave us the surface area. So let's see. Let's try again. Surface area is equal to the lateral area plus the area of the base, which is pi r squared. Now, lateral area I know is this, the 1/2 times 2 pi r times my slant height, which also simplifies to pi r slant height. So pi times our radius times our slant height. But I also know in this problem that my lateral area is 100 pi. So I'm going to say surface area is equal to, well, what was surface area equal to? Let me erase this. Because they give me what the quantity of surface area, so surface area was equal to 136 pi. Lateral area was equal to 100 pi. And then we have our pi r squared. So looking at my lateral area here, I have two unknowns. So I can't really use this formula, this equation to solve. However, when I look at the equation for the surface area, I know that I have one variable, and that happens to be the variable that we're trying to solve for. Remember, pi actually represents a numeric number. It is an infinite number. It goes on to infinity and beyond. It's a continuous number, it never ends. So pi does have a numeric value though. R also does, but we know what pi is. We can use pi on our calculator. We can't use we can't use R in a calculator because we don't know what that value is. So I'm going to start off by going back to Algebra 1, Integrated Math 1, and putting things in bubbles. For example, I have my 100 pi in one bubble, and I have my positive pi r squared in another bubble. So which bubble has your unknown? Which bubble has your variable? And it's this bubble right here. So I'm going to leave this bubble because it has my r in it. It has my variable. However, I'm going to do the opposite of this. So I have a positive. Remember, mathematicians are what? We are lazy. So if there is no symbol in front of a number, that symbol is a plus, meaning that value is positive. So I'm going to subtract 100 pi. Now don't let the pi trip you up, okay? Treat pi like you would a variable. So if you have 136x minus 100x, how would that look like? Well, you just take the quantity of x's and subtract. So if I have 136 pies and I eat 100 of those pies, how many pies do I have left? I have 36 pies left. Now on this side, my 100 pi cancels out. It undoes it. We moved it over. So now I bring down what my other bubble. The bubble I did not touch, I'm going to bring it down. So I have pi r squared. Pi is what? Pi is just a numeric value. So this is pi times r squared. So I'm going to put these into different bubbles. Here's pi, here's r squared. Which one has the variable that we want? This bubble. So keep that bubble. Don't do anything to that bubble. But how are these two bubbles attached? They're right next to each other. There's no symbol in between. But since two things are right next to each other, that means we have multiplication. What is the opposite of multiplication? Division. So I'm going to divide by what I don't want. I want to get rid of this pi because I want this bubble to be by itself. I'm going to divide by pi. Now this says 36 pies or 36 times pi. I have 36 times pi divided by pi. This is the part that feels super duper good to do. We're going to undo these by canceling them out. If you are multiplying by something and dividing by that same something, it goes away. So now I have 36 left over, and then here, again, cancel those out. I have 36 is equal to r squared. Things are looking very good. So now I'm going to take the square root of both. R is equal to plus or minus 6. However, R represents what? R represents the radius. Radius is a unit of measure. It's telling us half a diameter of a circle. So since radius is a unit of measure, we're only taking the positive value of that. Now, it doesn't tell us units. It just tells us that the lateral area is 100 pi, and it tells us the surface area is 136 pi. It doesn't tell us the units, but we still have to account for units. Now, you can write you can write units. Here's the thing, though. What are we trying to find? Radius. That's it. I didn't say surface area. There was no area in it. I didn't say volume. So since we're just trying to find one thing, and that one thing is radius, not area or volume, you leave it singular. So do not put this as squared. Do not put this as cubed. Radius is just one thing. So we have it singular. And we just say 6 units. All right, you guys. More examples, more examples. I'm actually going to pause this video right here, and then we're going to move on to composites.